Hello and welcome back. So continuing on with our VertexCache, in this video Lee is going to be implementing the Purge method. But real quick, I wanted to point out a question that I had for Lee once we had concluded the last video. I realized that he was doing an operation on vertices where he was actually removing from vertices a vertex out, and he did not have a lock on it. So I asked him, "Hey, aren't you concerned about locking this?" And your answer, Lee,
was no, not at all, because the only thing that calls remove is the purge operation. But I realized I had left this as public and it needs to be private. Because
okay.
the only thing that's really calling the remove internally is purge. I don't want anything external to be able to remove something from the array. Anything that's external that wants to flag something for removal is fine, but I do not want any other part of the code to be able to literally remove something from here. So everything has to go through the VertexCache for that to happen.
Okay, cool.
And the removal part takes place from inside the purge method, and the purge method handles locking.
Okay, fantastic.
Okay, so I guess that means we're doing the purge class now.
That's right.
All right, so let's drop down here to underneath our release holds and above our get height. This is going to be a private static return type void method called purge. Takes nothing in. And a while back when we were talking about purge, I said that it was going to be in a while loop, which means we need to be able to get out of it, which was the whole reason we had this quit method. So basically we're going to say, while we're not quitting, go ahead and do everything inside this loop. So what are we going to do? Very first thing we're going to do is we're going to take a nap. So we're going to sleep. And we're going to sleep for the duration of our purge interval. So when this thing fires off and we start the thread for the very first time, I don't want it to do anything until the first interval's up.
Right.
So we'll go ahead and sleep for that interval. After that, we need to lock our vertices. So we're going to perform a lock on vertices. This is where that lock comes into place that you were asking about.
Mm-hmm.
So now we lock our vertices. We're going to do a for each loop. And this one, let's see, I got to get this in my notes, which is on, about 8 lines of code. No, it's not that bad. But trying to think how's going to be the best way of doing the code for this one, because it gets kind of messy.
Okay.
To put it at least. I'm trying to think if I should present it all in with link all put together, or if I should break it up for readability so people can see what happens. But I think I will do it this way. So for each vertex in a list, we don't want to work with vertices as they are right now. We want to modify that list. So we're going to modify it using where. And okay, fine. I don't know why ReSharper is so good at picking up everything, but system.link. Whoa.
You jump back down.
Yeah, that's what I was saying. Whoa, that wasn't supposed to happen. Especially when you click up here already. Using system.link. Thank you. Now we can come back here. See, was that hard? All right. What do we want to do? Well, we're going to check our vertex. So V goes into, I'm going to compare datetime.now. I'm going to subtract from that our vertex's value, and this will be touched. So basically, I'm doing that comparison from our touched value the last time this vertex was touched, subtracting that from our now time, our date time now, which will give me a number that I would like to have in total seconds. So I'm going to take that total second and see if it's greater than our vertex TTL. So if it's greater than that, then I need to do a check. Whoops, come on. Dot enter. I'm going to do a check where this next condition is going to be V goes into Z. No, V goes into not vertex or vertices, so not V dot value dot hold. So basically we're building a list of everything that exceeds our vertex time limit and is not set as hold. So we've got all of those. And then from here, we'll take those and I'm going to set, how did this get changed to very nice? Set that to vertex. All right. Now from here, I'm going to set each one of those vertex dot value dot destroy me equal the true. So basically, all this is doing right here is looping through all of our vertices. And then we're going to do a check that is going to say, hey, anything that is greater than our time to live and is not currently in a hold state, we're going to go ahead and flag as true. And I probably need to put and not modified as well, just for completeness. And V not modified, or value dot modified. So that will take care of that. And I should also do a take, and this will be our purge limit. So we only do the first, by default right now, 1,000 of them. Where this comes in handy with the purge limit is, let's say you had 1 million of these. You don't want to go through all 1 million in a single update. It will take a very long time, and you might notice some lag. So we'll only do our purge limit worth of these. After we've flagged those, we also want to make another temporary list. So verts equals vertices where V goes into V dot destroy, V dot value dot destroy me. And from here we're going to take our purge limit worth of these, and then we can go ahead and set this to an array. Well, do I really need it in an array anymore? Yes, I do. And I'm going to turn that into an array. Now the reason I want to do an array with this is because I want to reverse iterate through it. So I'm going to take our verts dot length -1 while I is greater than that. Then I will remove verts sub I dot key. And this will send in our key for removal. Okay, now that's pretty much it for our purge method. But we have to go back up and we need to revisit our constructor. So we come back up here where we said we need to put our purge stuff. In here, we need to go ahead and take our purge thread, set it equal to a, let's see, what do we need to set it to? A new thread, and we're going to pass in the purge method to it. And then we tell purge thread to start. That will handle the purge part. So basically, the moment this thing kicks off, it's going to start off our purge thread, and our purge thread is going to continue until we call quit. That's pretty much all there is to the purge operation. The big trick with it is fine-tuning how fast your computer is, and basically how often through purge interval do we run this purge operation, and how many of these flaggings to destroy me, and how many do we remove at a given time are we allowed to do through each iteration of the purge. What you'll find is if your vertex cache gets too large and these numbers, or the purge limit is too high, or the purge interval is too low, you're going to see these spikes that happen during the purge operation, and you'll also see your garbage collector come to life more often, causing another issue.
Okay.
That being lag.
All right. Well, that should be everything that was going to be covered in this video. There.
Yep.
Now
Just
perfect.
Now it's perfect. I had to get the wares to line up. Otherwise, it just wasn't right.
Right. All right, ladies and gentlemen. Well, with that, that will conclude this video. And starting in the next, we're going to be taking a look at calculate normals. Thanks a lot.